recording part. Okay. All right. I'll go back here. Yeah. So first of all, chapter 5 is on the roots, basically to radicals. We have different type of radicals. So, um, so that topic on the rational exponent. So the radicals has a lot to do with the exponent. We're going to review some of the exponent stuff along the way, as well as the exponent and the roots. And start with some introduction of the radicals, right? Radicals, typically we have a root, right? Times the root of a, something like that, right? And then the a is what we call the base, and n is called a radicand, right? So the simple one could be like square root of 2, right? Example could be square root of 2. Right? And then the square root of 2 is approximately 1.414. Something like that. But we're going to focus on those special roots, special square root. Let's start with the special square root. And then we're going to come up with the general pattern for all the root, special square root. And the first one is, what is square root of 1? It's 1, right? Yeah. And how do we know it's a square root of 1? Square root of 1 must be 1 because, and we're going to transfer a little bit. For square root, by default, the index will be 2, right? Our radicand will be 2. Index is 2. So will be 1 square. So right here, the exponent and the root, they offset each other. That's how we end with 1. Similarly, like square root of 4. It's 2. We know that by memory, right? But the rationale behind it is, so we have a general pattern here. It's a square root of 2 square. So here 2 and 2 offset each other. The exponent, or another way of saying this is we can do this. 2, right? Keep the base and use the exponent divide by the index and get 2 to the first. That's why it's 2. Besides memorizing all this special root, right? This is something we can do. And we know that square root of 9 is 3. Why that happens? Because it's square root, and then it 9 is 3 squared. So that's why it's equal to 3. And very similarly, square root of 16, it's 4. And the reason it's 4 because it's square root of 4 squared. And that's why it's 4. So basically, what's the common characteristics of this special root, special square root, special this 1, 4, 9, 16? What is that a pattern among all those numbers? What do you think? Anybody have a suggestion?
No, perfect square.
Exactly, right? Very good. Yes, that's exactly the idea, right? Albert. So basically they all perfect square. You're taking the square root of the perfect square, you will get a well random number like 1, 2, 3, 4, like what we have here. And also I'm gonna write some more, right? So 5, we know that. Square root of 36, 6. This is something you can try to memorize, or if you do not want to memorize, then use all these properties I just showed you, right? Just turn into a something like this, and then simplify from there. And this is one of the properties we use a lot. You're going to see that we're going to do a lot of practice today based on this, using some of these properties. And then I'm just going to write all those commonly used ones, right? Square root of 49, 7. Square root of 60. We already, yeah, I skipped 60. No, I didn't. So square root of 64 is 8. And then square root of 81 is 9. And we know that square root of square root of 100 is 10. And 11 square root of 11. If you do not know what that next number, perfect number is, it will be 11 square. 11 square is 121, right? So that will be 11. So we can write some more, but you can keep going, right? Because we have infinitely many perfect squares in the number system. So that would be 12, and definitely 169, that would be 13. And then 14, that would be 196, right? I think that's good enough for now. So 196 is 14. And we could keep going, right? Square root of 225 is 15. But that's, I think that's good enough for now. And let's take a look at cubic root, right? So this is square root, some special square root. Let's look at special cubic root. Very similar here, right? First number it will be cubic root of 1, and we know that is 1. Why is 1? Because it's cubic root. Why you can rewrite it as 1 cube. Now, as you can see, exponent and the root index of root offset each other. They are the same. Or you can do this 3 over 3. That becomes 1 to the first. That's why it's 1. And this is the transformation behind it. Secondly, cubic root of 8 is 2, right? Because 8 is 2 cubed. And one more time, this exponent and the root index of the root cancel each other and end up with 2. Okay. Third one, 27, cubic root of 27. And that would be 3. Okay. And, how do you know it has to be 3? Because 27 3 cubed. So all of these numbers, right? It's what we call the perfect cube. So so this is the idea, right? How we come up with all this special root. So that's how we derive it. I'm gonna write a couple more. So cubic root of 64, that would be 4. And the reason why that is 4 because 64 is 4 cubed. So yeah. And what 50 cubic root of 125. That's going to be 5. And this is all the commonly used ones. We use a lot. That's why I want to show you guys before we get started. So let's go to 5 and 6. 36 times 6, 216, right? The root of, yes, 216 is 6. Because this is cubic root of 6 cubed. So, etc. So we can keep going. But again, so you see the general pattern here is when we have a perfect cube, we'll be able to simplify that accordingly. So any questions so far? All right. So let's go back to the webbook, and we're gonna start talking about go over some of the questions from the webbook. Okay, let's go back to our book. Yeah, it's fine. All right, so we are on section 5.1 right now. Okay, so let's go over some of the questions here. Start with problem 1. Okay, square root of 481, right? So I'm gonna show another. Okay, no, 100 is too simple. Let's try that one. It's okay. What do you think? Any suggestion? how to simplify this. Okay, so you always look for if this is a perfect number, right? Is this a perfect number? If not sure yet, no problem. We can factor this, right? We can factor as we know that 4 going to that, right? So 4 times 121. Yeah, so that means it will be 2 squared and 11 squared. And if you, so maybe we can just simplify this. So 2 squared, square root of 2 squared will be, you can split up as 2 squared, square root, and then square root of 11 squared. Right, so that we can simplify this. By default, we usually don't write this 2. We omit it. So the 2 times 11. Right, that will be 22. And so basically, when you have a square root of AB, like let's say a root nth root of AB times B, you can split up as nth root of A times nth root of B. This is something we can do, right? And this is what, and also if you see this directly, if you notice that 484 is 22 squared, it's 22 times 22, which is 22 squared. Then actually you can get to the answer even quicker. But it's okay, you can do it either way. There are so many different ways of handling this type of problems. So you can always try a different way, new way. Okay, so let's look at the next question. Yes, you're gonna try this one. You need to show me another. Yeah, let's try this. Anybody want to share your answer? What will be the answer here?
It's 5.
It's 5, right? Very good. It's why is 5?
5 power 4 is 2 5.
Very good. Yes. So that means 625. 625 is equal to 5 to the 4th power. You're not sure you can break down like this, right? 5 times 125, and 5 times 5 times 25, 5 times 5 times 5 times 5. That is why it's 5 to the 4th power. And then right here, once we get down to this, then you see the power and index. They offset each other, so we end up with 5. So that's basically how you tackle this type of problem. Let's go back to question. Yeah, so the answer is 5. All right, so what if we have a multiple terms, right? Something like this. Let me show you a question here. 225x to the 6. How do we simplify this? And also notice that still here x must be greater or equal to 0, right? This is necessary because this is square root, right? For all the even root, when we take out the radicals, we should end up with the positive answers, right? So the x greater or equal to 0 is needed, right? To make this root valid, a valid root, not a or defined, right? Make it defined. So right here, square root of 225, we know that 225 is 15 squared. And then you can rewrite x to the 6 as x cubed to the second power. Now we know this is perfect square, so we can split up as a couple terms. Square root of 15 squared, square root of x cubed squared. So now square root of 15 squared is 15. Square root of x cubed squared, that will be x cubed. So the answer is 15 x cubed. Okay. Any question about this? All right, so it's 15 x cubed. Check it. Yep, it's good. Okay, so I'm gonna create a new one for you guys to try. Show me another. Okay, okay, you guys try this one. So the answer here will be square root 81, right? We treat as a 2 square root x squared. So square root 81 is 9. Square root of x squared is x. So the answer is 9x. Here, x must be greater or equal to 0. Okay, any question? All right.
No.
No, okay, very good. Yeah. 9x. Check the answers, it should be good. So this is a very basic like trainings on these radicals, and I'm gonna get to some complicated ones in a second. Yeah, let's try this one of this cubic root. I'll try this one first, and I'll let you try another one. So going back here is cubic root. So basically, still we're gonna split up as 2 cubic root, just to make it easier to approach. So cubic root of x to 15. Now we're gonna turn each one of them as a perfect cube, right? So 125 is a 5 cube, and we know that cubic root of 125 is 5. And here we're gonna split x to the 15th as x to the 5th, the third power, right? So we basically, turn this as, so this comes from this particular property of exponent, right? Let's say x AB, it's x to the a power raised to b power, right? This is some kind of like exponential transformation we can do. So that's how we go from this x15 to x15, gonna write it as x to the fifth times 3, right? So it will be x to the fifth, the third power. And that's how we do this transformation. And once you have the root and the index and the power, index and the power are the same, so we get 5 and x to the 5. So it's 5x to the 5. That's the correct answer. Yep, check it, so it should be good. Yep, so that's, you guys maybe try one of those. Okay, you try this one. So while we're doing this, I'm gonna call attendance. So high tech. Are you here? High tech. Yeah, you here, right? High tech. Okay, so I mark you. And Abra is here. Amaya. Amaya. Maya is not here today. So Michael.
Here.
Yeah, okay. Okay. Immersion. Immersion.
Here.
Okay.
Professor called my name because I think there was a problem with the network.
Okay. High tech, right?
Abroad. Abrar.
Abra, I got you. Yeah, yeah. I see you answer the question, so I notice you here. So I mark you here. No worries. Okay, sure. Nazareth. Nazareth here, right?
Yeah.
Okay, very good. Yeah. And Daniel is here. Okay.
Yes, it's here.
Okay. Satimonia, are you here?
Here.
Okay. Sida.
Yeah, I'm here.
Okay.
Sigdar Mahmoud.
Yeah. Okay. So Sida or Skida? What's the right
Sigdar.
pronunciation? Cedar. Okay, yeah. So I pronounced it right.
Sigdar. Yeah.
Yeah.
Yeah, okay.
Professor
Thank you.
Noah pronounced it wrong. Okay.
Okay.
Okay. Cedar here. Ivan.
Here.
Okay. Good. Han. Here, right? Yeah.
Yeah.
And then Count. Count.
Here.
Okay. Victoria. Victoria here, right? Yeah. And Li Shan. Liang.
Yeah.
Yeah, is that the right pronunciation?
Mission.
Mission. Okay. Okay. Very
Yes.
good. And then Guangyu. Guangyu. Yeah. I think.
I'm here. I'm here.
Yeah, okay. Very good. All right. So I marked everybody. So it's good. So let's go back to the question we had earlier. Yep. And finish it. All right. So the cubic root is split up as cubic root of 27 times cubic root of extra 9. Now we know cubic root of 27. One more time, we'll do the full transformation. And same thing here, cubic root of extra 9 will be x cubed to the third power. And again, this compound is, right? Cube times x cubed times x cubed. And that becomes x cubed to the third. And you can also look at it like this, right? 3 times 3. So we take the inner layer x cubed and the outside layer will be to the third power. And that's how you do the transformation here. And once you simplify, you cancel that, you get 3. And this one, cancel the cube and also the cubic root. So we get x cubed. So the answer is 3x cubed. Any question about this?
No.
No. Okay, very good. So check the answers. Should be good. Yeah. All right, that's it. It will get a little bit more complicated, just in terms of the difficulty level, right? So, and this is the one that we have multiple variables. Again, we just pretty much follow the same rule. No matter how many variables inside the root, right? We still just tackle that in the same, exact same procedure. Okay, so let's look at it. Here we go. So split up, usually that will help a little bit, especially when it gets more complicated than this. So 15, then the cubic root of y to the 12, one variable and put in one. And then we know that actually 15 is actually 5th to the third. And here y to the 12th is y to the 4th to the third. So and from there we just simplified cubic root of each other, and we get x to the 5th times y to the 4th. So the answer is just this. All right, so going back here, I'm putting the answers x to the 5th times y to the 4th. Yep, they is good. So let's try another one. This show another. Yeah, you guys try this one. Right? All right, let's go over the solution. So similarly, you just put cubic root of x to the 9th, and then cubic root of y to the 6th. I'm going to show you another way of doing this, right? So you can also do this. You can just do, once you split up, you can do now the 3, using the power by the index to get a result. And then also similarly, so you don't have to do that transformation thing. So 6 over 3. Okay, so we get x to the 3rd as y to the 2nd. Just another way of looking at this, right? So basically, all the roots, let's say, nth root of x to the a power and then y to the b power, right? You can always rewrite it as exponent will be x a over n times y b over n. This is also a very commonly used technique to simplify to turn the radicals into the exponent, and the vice versa. You can also going backwards, turning the exponent into the radicals. So just another way of looking at this. Okay. So this is going to be x cubed minus y squared. Okay. Let's do it. Yep. So let's move on to the next question. Yeah, so this is the one, we talked about earlier, is how we turn the exponent into the radicals and then simplify, because it's harder to see what is 36 to the half without using the calculator, right? But if you turn into the square root, into the root, then it's actually kind of easier to do that. So let me show you how to do the transformation here. And back here. Here we go. So if you have exponent, let's say x a over n, right? And then you can actually turn it back to the root. This will become nth root. So the denominator becomes index for the root, and the numerator becomes exponent for the base, for base a, right? So this is how you go from the exponent to the root. Similarly here, 36 to the first, right? Power, numerator is power, denominator 2 is the index. And then usually by default, we just omit that 2. So it's just basically 30, a square of 36, that's it. That's how you go from exponent, especially with the fractions, back to the square root, back to the root, radicals, and then back to the simplified form there. Okay, this is very commonly used technique. If you move on to calculus one, yeah, I teach calculus sequence, so I know we use this technique a lot in calculus. Okay. You try another one, right? Try this one. Here we go. Yeah, we try this one. All right. Anybody want to share answer? So again, 225, 15, right? Yes, very good.
15.
You guys both have the right answer. Very good. So it's just square root of 225. Read that. And square root of 225. That's 15. Because 225 is 15 squared. Okay, so the answer is 15. Very good. So you guys are comfortable doing this. Very, very good. So, check the answer. It's perfect. Yes. So sometimes it could be a negative number, right? So we haven't dealt with the negative number yet. So let me show another one. It's not those common numbers. Let's try 343 minus 343. Yeah. So three. Let's see. This will be some numbers cube. Let's see what number that is. Yes. Okay. All right. So let's look at this question here, and I'm gonna show you how to do this step by step. What if it's a negative number? Very similar, right? Try to turn into a cube. Some numbers cube, and then it turned out to be this 343 is a 7 cube. So this is an important piece of information. 7 cube equal to 343. Something we usually use, but we get experience when we practice more problems. And here, so basically we were turning. So basically, this minus 7 cube, right, will be minus 343. And you're probably going to use this number right here. This is what we want. So first of all, we're going to turn it back to the cubic root. So it will be cubic root of minus 343 to the first. But you usually omit that one, right? It's not necessary. So it will be cubic root of minus 343. We know that this is equal to negative 7 cubed. So it's cubic root of negative 7 cubed. And again, cancel the power, then index of the root. So give us negative 7. So the answer is negative 7. Yeah. So let's check it. It should be good. You guys try one. Yep. Any suggestion will be the answer? Minus 64.
-4.
Or, yeah, -4 to the third, right? Very good. So also, another way of looking at this is if you don't want to take the root, right? You can do this and this and then 1/3. And as you can see, 3 and 1/3 using exponent. So that's going to be -4. I forget there's always several ways of doing this. Forget to mention this to you guys. So you can either turn it back to the root or you can just stick with the exponent, right? And then cancel that, and then simplify. You always yield the same results. Just a different way of looking at it. So the answer is -4. All right, and let's see. Next question. 30 to 1/5. This is fifth root, right? 1024. And 10 and 24 is very, very interesting numbers, right? You know that computer system was built based on the binary numbers, right? 0 and 1. And then 2 to the 5th is kind of like 5 commands in a row, right? 0, 1, 0, 1, 0, 1, 0, 1. 5 commands in a row. So this number reminds me of this computer system. So you have two choices on each spot, right? 0, 1, 0, 1, 0, 1, 0, 1. Two options, two choice, two choice, right? And if you get 2 to the 5th, that's a no, that's not. So we're gonna have more, right? 2 to the 5th, 1024. I think it's 2 to the 10th. Yeah, it's 2 to the 10th. So 2 to the 5th. This is just 5 digits, and then we get 5 more. 0, 1, 0, 1, 0, 1. Two choice, two choice. So it's 2 to the 10th power. 2 to the 5th, what is it? 4, 4, 16, 32, right? This is all 32. And 32 times 32, that is 1024. So you can either do this. You can either do 2 to the 10th power, 1/5. Get the answer. So that would be 2 to the 2nd. 10 times 1/5 is 2. So 2 to the 2nd. And another way of doing this would be turning back into the root. It's fifth root. So we know this is 2 to the 10th power, right? 1, 2, and numbers. We're going to do 2, 10 over 5. That's another 2 to the 2nd. So totally up to you, right? Whichever you feel easier to tackle the problem, you use that. So here the answer is 4. Okay. All right. And then let's see. I'll let you try one of them. No, not this one. It just did it. No, it doesn't. It's okay. So I guess you guys can try a different problem. It's okay. All right. Next problem. Yeah. So now I guess you try this one. Show me another. Yeah. Try this one. So again, a couple different ways of doing this. First one is turn the 27 as 3 cubed. And you're gonna do the exponent and multiply the inner exponent by the exponent outside. So 3 times 2/3. And we end up with cancel the 3 to the second power 9. And if you want to do the root, right? Denominator becomes cubic root, and then we get 27 squared. And here we're gonna do 27 squared actually is 3 cubed per second. Then we do cubic root of 3 to the 6, and we do 3 using the inner exponent 6 by index 3. So 3 to the second is 9. I think this is a slightly quicker, but again, I just want to keep both options open so you can use either method you like. Okay, so the answer is 9. So let's see. For this is very similar one. I guess you can try one of this, no problem. Sometimes it looks like this: 25 3 to the second, 302. Hey, anybody want to share the answer? So it'll be 5 squared, right? And then 3/2. So and will be 5, 2 times 3/2. Cancel the 2, we get 5 cubed. 5 cubed is
15 or 125. So
yeah, 125, right? Very good. It should be 125. And I skip the other one because it's slightly quicker. So let's go back. 125 is the answer. Yep, what if it's a negative exponent? Let's try one of this. It's a negative exponent. Show me another. Okay, let's start with this one. You could also, I think exponential transformation is easier. So 9 = 3 squared. Then we get -3/2. Still, we're going to multiply 2 by -3/2. I'm going to simplify this, right? So it will be 3 to cancel the 2, then -3 power. Now, typically, the easiest way of doing this would be this: make a fraction, flip this to the denominator, and then put back the invisible 1. So it's on the bottom is 3 cubed. So it's 1/27. Okay. That is one way to do this. Also, if you would like to do the root, right? So we can do this. So it's gonna be 9. So the square root of 9 to the 3rd power. Okay, so then we're gonna do this. Square root of make a fraction. So it will be a flip to the bottom, so it will be 1 over 9 cubed. Square root of 1 over 9 cubed. Now it will be square root of 1 over 9 is 3 squared. So this is 3 squared to the 3rd power. So this becomes 1 over 3 to the 6th. And you're gonna split out as a square root of 1 and square root of 3 to the 6th. And square root of 1 is 1. So 3 to the 6 will be 3, 6 by 2. So 3 cubed. 1 over 3 cubed. That's 1 over 27. The same result. I think this is probably slightly quicker doing this using exponential properties. So the answer is 1 over 27. So that's any question about this?
No.
No, very good. Oh yeah, this gets a little bit complicated, right? So let's try this one. Okay, so still is the exponent, and then yeah. All right, let's go over the solution here. First of all, we want to get rid, if you want to get rid of this negative sign here, let's say something like a over b, right? To negative m power. So we can use the reciprocal of the fraction, so b over a, then it will offset this negative sign. So it will be this. And then we can distribute the power to both b to the n and then a to the n. So the very useful technique is to get rid of the negative sign in front of the exponent. So similarly here, we're going to flip the fraction here, use a reciprocal, so use 27 over negative 25, then put 2/3. Once you flip it, then we automatically cancel the negative sign. So we can do, because 27 is 3 cubed, right? And 125 is 5 cubed. So So one way to do, if you want to stick with the exponent, that would be 3/5 the third power, extract the power outside, and then to 2/3. Now using the exponential property, right? So basically, if you have a m over a to the m over b to the m, you can do a over b. That's exactly what we do here, right? This step, we stick to 3/5 to the third, and then 3/5 multiply 3 and then 2/3. Cancel the 3, we get 3/5 to the second power. So that will be 9/25. Okay. Basically, that's how you do it. If you want to take the root, right? Taking the root, I think you're still gonna do the transformation first, meaning get rid of that negative sign first. So you get 27/25. That makes it so much easier. That 2/3. Now we can turn to the root of this 27/125. The second power. Now we do cubic root. Similarly, 27 3 and then 125 5 cubed. Second, and we're gonna do cubic root of 3 to the 6, and then 5 to the 6. Now you're gonna split it as two different roots. Then we're gonna get cubic root of 3 to the 6 and cubic root of 5 to the 6. And we apply that property 6/3, 5, 6/3, and 3 squared over 5 squared. It's 9/25. I don't think this is probably slightly quicker to stick with the exponent. 9/25. Yep, so that's pretty much everything from this first section, which is a rational exponent. And then we're going to move on to second topic today, which is expressions involving rational exponent. Expression with a rational exponent. And basically, we just apply some of the properties and then techniques to simplify, right? To simplify as much as we can. So let's start with this one. Another. So we have this rational expression. So basically, we just distribute it first. So x to the 2/3 times x to the 1/3 plus x to the 2/3 times x to the 4/3. And very similar, very basic properties a to the m times a to the n. To keep the base, we add in the exponent. If you have a to the n power, so it becomes a to the n. So when we multiply two exponents with the same base, keep the base, adding the exponent 2/3, adding 1/3. Similarly, for the second one, same base, right? Make sure they have the same base, 2/3 times adding 4/3. But again, on the numerator, on the exponent, they both like fractions, so you can just add them up, sum up. So the first one becomes 2/3 plus 1/3. That's exactly 1. And then 2/3 plus 4/3, it will be 6/3. So that's second, right? 6/3 is 2. So this is x plus x squared. Check the answer. It's good. All right, so you try one of this. All right, let's go over the solution. First, similarly distributed, so you get x 5/7 times x 2/7, adding x 5/7 times x 9/7. So keep the base, adding exponent, you get 7/7. Keep the base, add those two exponents, 14/7. So it becomes x to the first plus x to the second, so x plus x squared. Same result like the previous one. Yep, so let's look at next question. Yep, so you get a little more complicated like this. All right. All right, so we're gonna distribute it, right? Just like the other one. And then right here we have 5x. So you're gonna multiply the number first. So when you multiply 3 and 5 and 3, you get 15. You're gonna multiply x to 6/7 times x 8/7. So it will be x 14/7. And then for the y to the 1/5 times y to negative 1/5. 1/5 and then negative 1/5 becomes 0. So any variable to the 0 power become 1, right? So y to the 0 becomes. And then similarly for the second term, 5 times -9 is -45. Then we move on to the x variable, x to the 6, 7 times x to negative 6, 7. Again, they have opposite exponent, so offset each other get 0. And for the y part, y to 1/5 times y to 1/9/5. So it's y 10/5. Then we simplify, right? So 15x squared minus 45y squared. You just pair them one by one, right? Number goes together, variable with the same base goes together, and simplify using the exponential properties. Then we get the answer 5x squared minus 45y squared. No, 15x squared minus 45y squared. Can we do it? You try one. Yes. All right, let's go over the solution here. So first of all, we tackle the first term, 5 times 4 gives us 20, then x to the 6, 7 times x to the 8 over 7 would be x. Adding the exponent would be 14 over 7. For the y part, they offset each other, exponent offset each other, equal 0. And then second term, 5 times -6 minus 30, and x to the 6 over 7 times x to negative 6 over 7 offset each other at 0. And then for the y part, 1 over 7 times y 13 over 7, adding them, you get 14 over 7. Then we simplify from there, we get 20 squared 1 minus 30 times 1 times y squared. So the answer is 20x squared minus 30y squared. Yep, so any question about this? Minus 30y. Yeah, it's good, correct. Yeah, you try this one, right? This is not a, just FOIL this and then combine like terms if possible. One second, right? Let me, I think maybe I forgot to, let me go back to this. Let me see. To have an option to, maybe I forget to apply the settings here. Yes, I forgot by that. So I just quickly set up this and I will go back. Save change. And we are on problem 3. Yep. Show me another. Okay, you try this. So let's go over the solution. So we FOIL this. Actual 2/3 times actual 2/3, adding 2/3 and 2/3, you get 4 over 3. And then a second term will be this actual 2/3 times -5, -5 times actual 2/3, and +1 times actual 2/3, 1 actual 2/3. The last term is 1 times -5, it's -5. And the middle two actually is the like terms. You're going to combine them, x4 over 3. 1 minus 5, that's -4. -5 adding 1 is -4. Just basically combine the coefficient and keep the exponent. And then -5. And some question may ask you to factor, right? Going backwards. You get this result and then going backwards, factor this, let's say trinomial. And that's how you do it, right? You can just, you do this. You break down this x4 over 3 by x 2/3, 2/3. And break down the -5, right? Decompose it. You get -5 and 1. And you combine that, you get -4. So that's why you end up with this. This one, the second term is by the first term. Right? So you can going back and forth on this. So this is x raised to, if you want a fraction, get this fraction symbol over 3 minus 4 times x 2/3 over 3 minus 5. Okay, and let's do it. Yep, try one of these. All right, let's go over the solution. So you can FOIL this by expanding as this, but I'm going to show you a quick way to get it. Expand it as this form and then FOIL this. And then the shortcut is this. You want to do first term x to the half, right? Square that. Okay. And then second term will be 2. It is 2 times this 2 times x to the half. Okay. The third term will be 2 squared. And then once we get down there, then we simplify. Half times 2 becomes 1, so this is actually first plus 4 times x to the half and 4. So the answer is just going to be x plus 4 x to the half plus 4, right? And notice that sometimes we may have this, and they want you to go back. And you can do the same thing, similar thing, like factor by using the method I show you. So the x to the half to the half and plus 2 and then plus 3. And you get actually this form. So the answer, that's the answer for this question. So x plus 4 times x to the half, then n2. Let's do it. Yeah, it's correct. All right, you try one of these. Let's go over the solution of this problem. And this is exactly the difference of two squares. And becomes a squared minus b squared. So x half squared minus 3/2 squared. Simplify, half times 2 becomes 1. 3/2 times 2 becomes 3. So the final answer is x minus 27. All right, so let's try some of the division. So division of the rational expressions. Okay, try this one. So you can divide it one by one, right? So split out. That's 49 x to the quarter over 7 times x to the quarter first term. Second term, 14 times x 3 over 4 over 7 times x 1 over 4. Now for the first term, we can cancel these common terms. 49 by 7 is 7. And then 7 going to 14 two times. And for the exponent part, you just do 3/4 minus 1/4. And that turned out to be half. 2/4 is half. X 2/4 is half. So it's 7 plus 2 times x to the half. Check it. So we end up with the correct answer. You try one of this, right? Show me another. All right, let's go over the solution here. So first of all, you can divide that. Split out, right? X over 2 times x quarter. And that's first the second term, 6 times x 3/4 over 2 times x 1/4. Now simplify from there, 4 by 2, that's 2. And then the other one get cancelled. 6 by 2. Any question? Sita, you have a question?
No.
Okay. So x 3/4, so you do 3/4 minus 1/4. But for the exponent, so 2 plus 3 times x to the half. So 2/4 is half. It's 2 plus 3 and then times x to the half. Yeah, so this one is about factoring. Factoring, just like what we did, I showed you earlier, right? So we can actually factor this kind of like, it's kind of like a trinomial. And just have to break down the exponent carefully. So go back here and show you how to do this. So now you're going to break down the exponent evenly here. So that will be x to the 1/3 and then x to the 1/3. And then for -18, you would do 2 and 9. 9 and 2, right? And one of them must be negative, -9, probably 2. How do we know this -9? Because combine them, you should get -7. So that's why this should be the proper factoring. 3 terms. This is the first term. Last term, middle term, you can cross multiply. So -9 1/3 plus 2 times x to the 1/3. Combine them, you get -7 x to the 1/3, and matches with the middle term. So now we get 2 factors, x to the 1/3 plus 2, and then x to the 1/3 minus 9. So the other part is x 1/3 minus 9. So that'll be it. Okay, so you try one of this, right? You guys try one question like this really quickly. All right, let's go over the solution here. So x to the 1/7, x to the 1/7, and break down -27 as 9 and 3. Or you can do 3 and 9 to keep it consistent. Let's do 3, 9. And so first term is skewer here, last is skewer here. So let's skewer the middle term. So 3 x to the 1/7 minus 9 times x to the 1/7. Subtract it, you get -6 x to the 1/7 middle term. So we do all 3 terms. Now we just split it into 2 different factors. X to the 1/7 minus 9 the second factor. Any questions about this?
No.
Okay. So x to the 1/7 and minus 9. Let's do it. It's good. I think we finished this section as well. So now let's move on to the next section, which is simplify the radical expressions. Let's start with some practice. 5.3, simplify radicals. So now the earlier example is we have all the radicals, but we can evenly, right? We can simplify that fully and without radicals anymore. But most of the questions we're gonna deal with is we're gonna deal with some of the numbers. We can only partially simplify the radicals like this one. Let me quickly show you. You can break down the number as the largest perfect number here, and then by another factor. So here what we'll do is break down the 8 as so the largest perfect number that goes into 8 is going to be 4. We're going to break down as 4 times 2. So now here we're going to have a square root of 4 times square root of 2. The square root of 4 will be 2. Square root of 2. Right? So we have a partial of numbers, and then partial of them. Part of them will be part of them is a number, simplified number. The other part is the radicals. And that's a more common case for all the radical expressions. So 2 square root of 2. All right, so that's how we simplify this. Maybe you try one of this. Yes, try this one. 343. All right, so we know that 343 it's a 7 cube, right? Or 7 times 7 times 7. I think it's easier that way. So we do 7 times 7 times 7. And then we have a 7 square, right? 7 squared is 49. Square root of 49 and square root of 7. Square root of 49 is 7 times 7. Square root of 7. And that's how you simplify this. 7 times square root of 7. Check it. So we can answer. Let's look at the next problem. The radical of 175. So you try on with this. Show another. Yep, try this one, 45. Okay, so basically just break down as maximum perfect number, right? That goes into 45. That's gonna be 9 and 5. 9 is a maximum perfect number goes into 45. Square of 9, square of 5. So 3 square of 5. So the answer is 3 square of 5. It's a different version of the problem. Yeah. 3, yes, 3 square of 5. So for this one, with 3 square of 7. Should different version of the now be recorded. Should return to the yes no. Should return to the previous page. So then, so let's look at the radicals. We are on problem 3. 147. So it'll be 7 times 21, right? 7 times 7 times 3. So 49 times 3. So it'll be 7 square of 3. Yep, that's right. And yeah, you guys want to try this one. So another, this one is a cubic root. So you want to figure out the A and then the B, right? Both numbers. All right, let's go over this and then I'll let you give you guys a break. So it would break down 135. So the maximum cube number, perfect cube going to 135 be 27 times 5. So we know that cubic root of 27 would be 3. So cubic root of 27 and cubic root of 5. Cubic root of 27 will be 3 times cubic root of 5. Now here A will be 3, B will be 5. Any question about this? Yeah, well, good. So I guess we're gonna take a break. You guys gonna come back at 10:45, right? I'll see you in a bit. All right, guys, let's resume. So let's continue where we left off earlier. So, so let's move on to next problem. Wait, yeah, let's try a different one. T6, no. Let's try, yeah, 1029. That looks fun. Okay, so try this one, guys, and we'll talk about it in a second. All right, so let's go over the solution here. So anytime when you have a big number, like you try to decompose it, meaning break it down. So it looks like three go into this number. So one way to quickly know if three go into a number, you can add 1, 0, and 9. And then it looks like it's 12, right? So this is when you sum up all the face value of each digit, you end up with a number is divisible by 3. That means this whole number is divisible by 3. So 3 going to this number will give us 3 times 343. Okay. And then we know 343, that's a maximum cube number actually going to this 1029. And this is actually 7 cubed. Okay. So again, cubic root of 3 times cubic root of 7 cubed, they offset each other. So we end up with 7 and times cubic root of 3. Now A will be 7, B will be 3. And this is one way. This is from the number property of the numbers. You know, if you want to check whether or not this number is divisible by 3, you do that. Also, if this number, you can also use this method to determine whether or not this number could be divisible by 9. Since it's 12, so this is not divisible by 9. Okay. Because 12 cannot be evenly divided by 9. What if it's 18? Then it's okay, right? Let's say you sum up all the face value, it turns out to be 18. Then this number could be divisible by 9. That's a quick tip on this special numbers. So it'll be 7 and cubic root of 3. Okay, so A is 7, B is 3. Yep, that's good. Now we're gonna get to a little bit more complicated, meaning something like you have a number and also have a variable term. So let's create a new version and show you how to tackle this step by step. So whenever you have this, just like how we did it with the numbers, first of all, we're gonna decompose it as this is square root, meaning we're gonna look for the maximum perfect number going to 75. So that's gonna be 25 and 3. And I'm gonna look for the breakdown x to the 9, right? It could be breakdown as this is a perfect term and then x to the 1. So x to the 8 and then x to the 1. X to the 8 is the maximum power we can have, and it's even power. So now we have so we put a perfect number and then 2 together. So put into one exponent, and the other two put it together, 3x. I'll split up as a square root of 25, square root of x to the 8, and square root of 3x. So put the remaining terms, 3x, you should keep it under the radical because we cannot simplify further. So radical square root of 25 is 5. And then square root of x to the 8, you can do x a over 2. Index is 2, so x to the 4. Then square root of 3x. So that's how you simplify to the most extent. So 5x to the 4th and square root of 3x. 5 to the 4th times square root of 3x. Any question about this?
No.
Okay. So I'm gonna now you're gonna try another question, a similar one in a second. Just a quick note, right? I think I posted the midterm review already. Now we're gonna go over that 16 together, right, in class. And on 16, on 17, you're gonna take the midterm exam. We're gonna review for the midterm on 16. 17, we're gonna take the midterm exam. So let me show you where that is. We go back to our homework system, right? We're gonna see I post. I think I did post it. This one is midterm review guide, number 1. So you should see this one, midterm exam review. And your actual midterm will look similar to this. All right, and then let's go back to this question here. You guys gonna try this one. Yep, let's try this. Let's go over the solution here. Okay, so again, break down 75 as 25 times 3. 25 is the maximum perfect number going into 75. Similarly, break down the actual 7 as actual 6 and actual first. Then you're going to put the 25 and actual 6 together, and then 3 actual together. And you can split out into 3 radicals: radical 25, radical actual 6, and radical 3x. And then square root of 25, that's 5. And then this part, index, is going to be 6 over 2, that gives us x to the third. And square root of 3x. So 5x cubed and square root of 3x. Let me also show you something, right? If you instead of putting 3x, you put 3x to the half, you can actually turn this back to the exponent, right? Which will also work. No, they don't want it. Okay, but theoretically, right, you can put back as exponent. You can switch back and forth as exponent or as a square root. Yeah, I think this coding, all these questions coded by math professors all over the country, because this section is designated for simplifying the radicals. They still want answer to be in a radical form. That's why, but outside this course, right? Let's say move on to next level. Sometimes you may have to convert this radical as an exponent based on the need. Okay, that's you try this one. It's a cubic root and give a shot. And let's go over the solution. Since it's a cubic root, so you're going to look for the maximum cube, right? Goes into 54. It turned out to be 27, 2. 27 times 2. And then you break down x to the fourth as x cubed and x to the first. So these two are the perfect cube and also the perfect cube term. So we put it together, 27x cubed, and put the other two terms together to an x, right? So I'm going to split out as 3 different cubic root, cubic root of 27, cubic root of x cubed, and cubic root of 2x. All right, and then cubic root of 27 is 3. Cubic root of x cubed is x. And cubic root of 2x. So the answer is that 2x times cubic root of 2x. Any question about this? So a will be 3x. And will be 2x. Okay, it's good. Now we have more terms. I'll give you an extra try, right? Very similarly, just break down by 3 different components and then go from there. Yeah, let's try this one. Notice that this is needed because the square root and whatever comes out of the root must be positive, right? For all even root. And this is only restriction for even root. There's such a restriction that whatever variable comes out must be positive. The variable that comes out of the root must be positive. And then for all our root, there's no such a rule. Right? It could be either positive or negative. Depends on the number itself. So no restriction, but this is something it's going to be useful later when you move on to higher level courses. For all only even root, right? Like square root, fourth root. All right, so let's try to do this. So maximum perfect number goes into 45 will be 9. That's 5, and then break down the x to the fifth as x to the fourth, as x to the first. And break down the y to the eighth. No, y to the eighth is already a perfect term, so we don't have to break down. Let's stay as is. Now next thing is just to separate them, right? All the perfect terms together, number, including terms together, put the other one together, 5. It's 3 into 4 different square root of 9, square root of x to the fourth, square root of y to the eighth, and then square root of 5x. And here we simplify. So 9 would be 3. Here is x squared, y to the fourth, and then square root of 5x. Okay, any question about this? Okay, so 3x squared, y to the fourth, times square root of 5x. So that will be it. Let's look at the next problem. Problem 9. Okay, cubic root. Yeah, let's try this one. All right, let's go over this. So first of all, we're gonna break down the mini factor the 375, and then the maximum perfect cube that goes into this 375 is going to be 125. Nice great. And then x to the 7, you're going to break down as x to the 6, x to the first, and y to the 6. Now we have cubic root of 125, x to the 6, y to the 6. Those are all the perfect terms, right? Perfect cube. And then 3x goes together. Now we have 4 different cubic root, 125, cubic root of x to the 6, cubic root of x, y to the 6, and cubic root of 3x. Now, cubic root of 125, that's 5. And then x to the second, y to the second, and cubic root of 3x. That's our final simplified answer, 5x squared. So here, a becomes 5x squared, y squared. Inside of the cubic root is 3x. All right, both good. So that's pretty much everything on section 5.3. Then we're going to start talk about addition and subtraction of the radicals, which is section 5.4. So that means today you're going to finish the homework, right? This one all the way to, if you can finish 5.4, then you should finish up to 5.4. But I think we will be able to do a lot of questions here. Okay, so let's start with adding radicals, subtracting radicals. Okay, so that's also kind of like like terms, right? meaning radicals could be like terms as well. So let me show you quickly how to combine the like terms. That'll be the easiest thing to do. Just keep the radical as this, and then adding a coefficient. So let me give you some general properties in terms of handling this. Say we have a times square root of x plus b times square root of x. So typically it's like you can factor out a radical x. Like one way to look at it is this. You factor out that and then put a and a plus b together. So basically it's a plus b times square root of x. And so very similar here. They are like terms. Like so you can the shortcut just keep the radical 13 and then add into an 8, you get a 10. So the answer is 10 radical 13. So that's applying these properties here. That's how we get the answer. So the answer is 10 square root of 13. And let's see, next problem. Okay, you try this one. You guys try this one. Okay, let's go over the solution. So this one is subtraction. Again, we can factor out the radical 3. And then the first term 3x remains, second term 9x minus 9x remains. Simplify combine, you get negative 6x times radical 3. The answer is minus 6x times square root of 3. Yep, that's good. And this one is a little more complicated. So you need to simplify first. Again, I think I forget to give me 1 second. Let me just go back quickly. Fix a little issue here. I forget to put here. And that's problem 3. You can show me another. Yeah, let's try this one. Okay, so anytime we have a multiple radicals terms, first of all, we're going to simplify as much as possible. So for 125, maximum perfect number goes into 125. It's going to be 25 times 5. 20, it's going to be 4 times 5. 4 is a maximum perfect number, goes into 20. For 45, it's going to be 9 times 5. So 25, 4, 9. That's all the perfect number goes into each term. And you split up as a couple close radical 25 times radical 5 minus radical 4 times radical 5 plus radical 9 radical 5. Now this is 5 radical 5 minus 2 radical 5 and 3 radical 5. So you basically can just subtract the coefficient. 5 minus 2 is 3 radical 5, adding 3 radical 5. So not like 5x, right? Minus 2x plus 3x. Very similar. So just combine the coefficient 3x and 3x or 6x. It works the same way here. So 6 radical 5. As soon as they are the like terms, meaning under the radical is the same number and the index is the same. And sometimes you may have something like 5 square root of 5 minus 3 times cubic root of 5. Then these two are not like terms, right? Square root 5 is not the same as cubic root of 5. Then you cannot combine them, right? It's going to leave as is. There's just a little tweak. Index must be the same, and then the number must be the same in order to be the like terms. Okay, so the answer here will be 6 times square root of 5. Okay, problem 3. Yeah, you're gonna try another one similar to this. No, I'll try something else. Yep, this one is interesting. Simplify the radical expression. Try that first. Okay, let's go over solution here. So one more time. Maximum perfect number going to 54 is gonna be 9, 6, and then for 24, it's 4 times 6. 4 is the maximum perfect number going to 24. And for 150, it's gonna be 25. So all the perfect numbers, right? Usually we don't use one needed. 4, starting with 4, 9, 16, 25, 36, like keep going. So you can try, you can start trying the smallest one and all the way until you find the largest one. We call this maximum perfect number, and then simplify from there. Here's 6, square root of 9 becomes 3, and 6 remain under the radical. Square root of 4 is 2, and 6 remain under. And square root of 25, that's 5, 6 remain under. 18, radical 6 minus 8, radical 6, and 45, radical 6. Get 10 radical 6 minus 45 radical 6. Now subtract the coefficient, you get minus 35 radical 6. So the answer is negative 35 radical 6. Any question? All right, so we're going to move on to next one. Next problem. Let's see. Okay, so you get a little bit more complicated. Now you get both number and then variables. So let's create a new version. Yep, this one is good. Let's try this one. All right, confirmed answers here. 9x for the first, and then break down 8x 4 times 2. Second term, break down 18 as 9 times 2 square. Third term, break down 50 as 25 times 2 and x squared. Now you just simplify, so 9x square root of 4 times 2, right? 2. And the second one, you can just do slowly put 9x squared together and then times 2 minus 8. 25x squared times 2. And simplify 9x times 2, 18x divided by 2. First term, second term, 2 times 3x divided by 2 minus 8 times 5x divided by 2. So that was 18x divided by 2 minus no plus 6x divided by 2 minus 40x times divided by 2. And when you combine those two, you get 24x divided by 2 minus 40x divided by 2. Then subtract those two, 24 minus 40x. 24x minus 40x is minus 16x and radical 2. Any question about this? 16. That's pretty good answer. Check it. Minus 16x and radical 2. Yep, it's perfect. Okay, so we have couple terms and figure out what is A and B. So another, yeah, you try this one. right, let's go over the solution together. So first one, we take out 4 and cubic root of 56. Break down 56 as a times 7. A is the maximum cube number, perfect cube that goes into 56. And for 189, it's going to be 27 times 7. Okay, so 27 is the maximum cube, perfect cube that goes into 189. Now 4 cubic root of 8 becomes 2, and then cubic root of 7. Next one is a cubic root of 27 is 3, and then cubic root of 7. Now we get 4 times 2 is 8, cubic root of 7, minus 21, cubic root of 7. Now you subtract 8 by 21, you get minus 13, cubic root of 7. So the answer is minus 13, cubic root of 7. So it will be negative 13 for A, 7 for B. Check it. It's perfect. Yeah, today's the internet is not very stable on my side. So take a little while to load the page. Probably 7. So that. Yeah, so pretty much, this one is addition. Let's try one more, right? No problem. Try one. Yeah, let's try this one. let's go back to let's go over the solution here. So we have 4 times cube root of 40. So the maximum perfect cube that goes into this 40 is gonna be 8 times 5. And then maximum perfect cube going to 135. 27, right? 27 times 5, 135. And let's just simplify 4 times cubic root of 8, it's 2, and then we get cubic root of 5. And 2 times cubic root of 27 is 3 times cubic root of 5. So multiply, then you get 8 cubic root of 5 plus 6 times cubic root of 5. Now they're like terms, combine them, same number, same index. So 14 cubic root of 5. So A is 14, B is 5. So we finish this section here, 14 and 5. It's correct for both. Yeah, so now let's move on to 5.5. So definitely, right, we're gonna finish this for homework here, starting on 5.1 all the way to 5.4 today. I don't think we'll be able to finish 5.5, so we're gonna finish up that tomorrow. So next thing is the multiplying. So adding, subtracting radicals. Next thing is multiplying and multiplying radicals and sometimes dividing radicals. So let's look at the example here. Let's start with the multiplying. So if you multiply 2 radicals, this one we don't even need to. So you multiply 9 and 3, you get 27. Okay, and times square root 3 times square root 2 is square root 6. You can just and since we cannot simplify, we leave it as is. So the answer is 27 times radical of 6. So that is straightforward. And let's look at the next one. Yeah, so this one is from another. Still, we gotta dispute the radical 5 of both terms and then simplify. So radical 5 times radical 7. If you have radicals, root of A times root of B, usually you can just put it down as root of AB. And vice versa, you can go backwards, bring that to different root. Here you just do 5 and 7. And then for the other one, you'll be 8 times radical 5 times radical 5. This is radical 35. Also, if you have square root of A times square root of A, and this is square root of A squared, that is 8. So like what we have here, square root of 5 times square root of 5, that becomes 5. Multiply them, so get radical 35 and 40. So the answer is square root of 35 and 40. And we cannot combine the number by the radicals. You can only combine the like radicals or the numbers separately. All right, you try a question. Right, let's go over the solution. So distributed, you'll get square root of 3 times square root of 5 is square root of 15. And the other one will be square root of 3 times square root of 3 times 3. 7 times 3 is 21. So 15 and 21. And that's the simplest form. We cannot simplify further. So radical 15 plus 21. It's perfect. This one is similar, so we're going to move on to the next problem. Yeah, so this is slightly different. So you get a 4-year-old simplify and then combine our terms. Okay, try this one. All right, let's go over the solution. So for your this radical 2 times 4 radical 2 Radical 2 times radical 2 is 2, so it's 4 times 2. Second term, radical 2 times radical 5 is minus radical 10. And the third term, multiply those two, you get 4 times adding 4 times radical 10. And last term will be radical 5 times negative radical 5 times negative. Radical 25, that's 5. And from there, we just combine like terms. Put that invisible one, so 4 minus 1 is 3. 3 radical 10 minus 5. Now we combine the numbers. A minus 5 is 3 minus 3 radical 10. So the answer is 3 minus 3 radical 10. So it changed. So the new version of problems. Sometimes, you know, that the system did not could not keep up with the thing, so they create a new version of the question. So when we submit the answer, it doesn't check the answer for the correct problem. Okay, so the next problem. See, this is very similar. Let's move on to the next problem. Yep, so this one has variables. Okay, let's try one of this. Okay, give it a shot. All right, so let's simplify this. With this radical x times radical x is x, and radical x times -6 is -6 radical x, plus 3 times radical x, 3 radical x, and minus 3 times 6, it's -18. So now combine like terms, middle two are like terms. So 6, 3 minus 6 is -3 radical x, right over -18. That means if you want to going backwards, right, we can factor that into this. If you're going backwards. Okay, so now I'm gonna show you guys some other questions from another resources called Lumen, right? Let's try these two. Okay. You guys gonna try question 2 here, and also the question 3. And let's go over the solution here. First of all, this one, you will just break down, right? Radical, so x to the fourth, so radical 5. So the fourth is x. And for 180, it's 36 times 5 times x. Now, put all the perfect term, a perfect number in front of it. So x to the fourth times a perfect term and radical 5x. And the other one is radical 36, perfect term, and radical 5x. And let's simplify x 4 square root x to the fourth is x squared times radical 5x. Radical 36 is 6 times radical 5x. Now these two, 6 times x squared times 6x squared. Radical 5x times radical 5x, that's 5x. And we still got to multiply, so 6 times 5 is 30. X to the second times x to the first is x to the third. So the answer is 30x cubed. And for question 3 here, first of all, it's a cubic root. So this is a perfect cube, perfect cube. It's not a perfect cube yet, and not a perfect cube. So we will do this. Cubic root of 8, cubic root of 8 cubed equals perfect cubic root of x. Second one, we're going to break down 8 to the 8 as cubic root of a to the 6 times a squared. So a to the 6 is a perfect cube. And then x to the 14, you do x to the 12. 12 is the maximum number that goes into 3. And then x to the second. Okay. And now let's simplify. Cubic root of 8 is 2. Cubic root of 8 is 8 cubed is 8. And cubic root of x. Here, 3 cubic root of a to the 6 is a squared. And then these two goes together, put it on the side. And then the cubic root of x to the 12 is x to the 4th. Now you get cubic root of a squared times x squared. Now multiply this by this part. Let's simplify as much as possible. So 2 times 3 is 6. A times a squared, a cubed, and x to the 4th. Now we get a cubic root. Now we combine this two. Cubic root of x times cubic root of x a squared times x squared. So that's cubic root of a squared times x cubed. So now this is not done yet, right? We still got to simplify a little bit more. The cubic root of x cubed is x. So you get 6a cubed x to the 4th times x times cubic root of a squared. And multiply x to the 4th and x to the 5th. That would be 6a cubed x to the 5th and cubic root of a squared. That's the final answer. Any question about this?
No.
No, very good. So this one is 30 x. No. Okay, yeah, so let's try 6 and 7. We didn't see anything like this earlier, so let's try that. Let's go over these solutions here. So this one is split up as cubic root of 54 over cubic root of 54 and 64, right? Separately. And cubic root of 64, that's 4. And then on the top, we get a breakdown as 27 times 2. Cubic root of 27 is 3. So 3 cubic root of 2 over 4. So that's the answer. And for this one, it's easier if you have a, let's say, UA over root B. Turning into root of D. Depends on the need, and or you can split out. Like this one, we split out, so we're going backwards. And this one, we're gonna put it together, so it becomes root of 250 C5 over 2 times C5. Now we can cancel common terms. C to the 5 get canceled. 250 by 2 is 125. We get square root of 125. Then break down as 25 times 5. And square root of 25 is 5. So it's 5 square root of 5. Okay. Any question about this?
No.
No. Okay. Very good. Let's try question read. This question here. Okay, so let's go over the solution here. So for the top, you're just gonna break that as 32 will be a times 4, right? A is the perfect cube going to 32. Then the split up z to 24. 24 is the maximum number that goes into 3. So so that's why we use 24 instead of like 21 or something like that. So z squared. And then x 15, that's perfect, right? It's already 15 is divisible by 3, so keep as is. On the bottom, cubic root of 125. Bottom, they all perfect cube. So cubic root of 125 would be 5. Cubic root of z squared, z to the 6 is z squared. And cubic root of x to the 6 is x. So we simplify the bottom fairly easily. Now cubic root of 8 is 2. And then put this together, right? And then cubic root of z to the 24 is z8. And cubic root of x to the 15 is x to the 5th. And the other two term, this term and this term, goes inside the cubic root for z squared. Now on the bottom, we get a 5z squared and x to the 2nd. And we still get to simplify a little bit. So z squared go into z to the 8th. So here we do z using a minus 2. And then for x, it's 5 minus 2. And square root of 4z squared. On the bottom, this is gone. It's gone. 25 left. Just I will simplify cubic root. Now it's a 2z to the 6. And then x to the 2nd times square root of 4z squared by 5. Okay, so that's the final answer here. Okay. Any question about this? All right. Yeah. Great. Yeah. Let's try on 10 and 11. All right, let's go over the solution. Here, these two are like terms because the same radicals, exact same radicals. You can add 19 and 6, get 25, radical 11. These two are the same like terms. So radical 13 stays as is. A adding 35 is 43. The 43 radical 13. And then 11, only these two are like terms. Radical B. This cubic root of by definitely is not like terms here. So just leave it as is, 9. And then when you add 7 and 6 is 13. 13 radical B. All right, so, let's see. All right, let's try this question, 13. And let's go over the solution here. So it's an addition. So we're gonna make sure if you want to combine them, they have to be the like term. So let's see if they are like terms. So 4a to the fourth. So that's here, we're gonna break down this x to the 20 as a to the fourth to the root of 8 times x to the 18th, and then x to the second. And for the second term, and this a to the 13, you're going to break down as a to the 12 times a to the first. So 11 x to the 6 will be root of a to the 12 times a to the first times x squared. And then it's simplified. The only part we can simplify for the first one is this part. And this part on the second one. That's 4a to the fourth times cubic root of x to the 18th. It's x to the sixth. And then the other one is remains is cubic root ax squared. Our second one, 11 x to the sixth times cubic root of a to the 12 is a to the fourth. And then we get a cubic root of a x squared remains. That the under bracket and then the cubic root. Now let's simplify a little bit. So this is 4 a to the fourth times x to the sixth, cubic root of ax squared. The other one will be 11a to the fourth x to the sixth, and then this cubic root of ax squared. Now, they are like terms, which exactly like terms. So that means we can add up the coefficient, and the coefficient happen to be the like terms as well. So 4a cubed x to the 6 and 11, we get 15 a to the fourth x to the 6, and then cubic root of ax squared. Any question about this?
No.
No, very good. Yeah, so let's try yeah, let's try 18 and 19 here. All right, let's quickly go over the solution. So the first one is really radical A times radical A times, and then radical Z really inside of that, and then minus 7 times radical AZ. Then we cannot combine them because they are not like fractions. So we're going to leave as it is. Okay, so that's verse 18. And for 19, dispute it first. Then we simplify from there, so we get a cubic root x times cubic root of x plus 5. So it will be cubic root of x plus 6, right? Power, add up the power, you get x plus 6. Second one, 10 cubic root of x to the first times x to the 12 is x to the 11 is x to the 12. And then the third one, 9 times x to the first times x to the 17 is cubic root of x to the 18. And once we do that, then all of them becomes a perfect cube. So the first term is x squared, second term is x to the 4th, third term is 9x to the 6th. And we leave as is. We just did something like this already. Just quickly show you how to rationalize the denominators here. So basically, you're going to multiply the radical x, meaning multiply by the conjugate. In this case, by multiply both top and bottom by radical 6, and then you get the answer. Rationalize the denominator, and you quickly say the solution here. So on top, you multiply by square root of 6. On the bottom, you multiply by square root of 6. And then the square root of 6 is called the conjugate. On top, we just get a radical 6 plus 6. On the bottom is 6. And that's how usually rationalize. This is called rationalizing the denominator. And this is very useful to make you get to the calculus one. Calculus sequence, rationalizing the denominator. Multiply by the conjugate. All right, so that's pretty much everything for today. So